What's up people, welcome to my tutorial in anomaly detection. So in the previous video we had a run at the isolation tree implementation and looked at how you would implement it. We used a static CSV file. We used two different ones, and we looked at one data set that was not particularly good for this algorithm, and one that was a bit better for the algorithm because it was unbalanced versus balanced data. So in this video I'm going to have a look at the third way you can use this thing, because you don't necessarily have to use static data like we use in the other videos. We use a CSV file, right? So in this video, instead, what we're going to do is going to look at sampling the data from a stream. So in this source code here, I have this stream sampler, and what it does, it's using this system information package, npm package, and grabbing processes from my computer here. And then what it's going to do, it's going to sample from this thing here and going to cache it every second to disk into the samples JSON file here. So it's going to be a different sampling file, and it's going to run it like every second. It's going to dump it to disk. It's reservoir sampling as well. So if we look at this thing here, it's very similar, but it's going to run through the number of trees that we want to create, initialize the sampling, and then go through this thing here. If the sample is not filled up yet, you fill it up just with the other implementation. And the only difference really is in this thing here, that instead of using 1 over the size of the data set, we use 1 over the size of how many items you have seen so far. So this number is going to, since we run it every second, this is going to grow bigger and bigger number. So it's going to be less and less frequent that we do a swap of the sampling since the dataset grows. I do plus j here because I want to use the current iteration. I could have done not done this thing, and then I want to do a plus 1 so that I avoid 1 over 0, division by 0 basically. And I use this if I should sample or not. Otherwise it's exactly the same thing. Swap at a random position in the item with this sampling thing, add a random index in the sample, and then I print out swapping with probability, blah blah blah. So now if I just run this thing here, it's called stream sampler. It's gonna start sampling. You can see it's pretty frequent sampling in the beginning here. It's as the sample size grows, or the number of examples seen, it's going to be less and less frequent for it to sample. So you can see that here in the probability here, it's always decreasing monotonically with the probability of sampling, and it's never gonna converge, but it's going to decrease more and more and become like less frequent of a sampling. So if you run this thing here, it's good that you let it run for a couple of whiles to get some statistically significance. So if I run this over the course of a day, for example, I will have a data set that is statistically significantly representing that 24-hour period that I ran the sampling for. So I'm just going to keep this running here, and then I'm going to go to another terminal, and then let's go into the isolation forest thing. You will need to do some modifications here. First of all, read in the right sample. So read in the samples.json instead of the samples_b for the breast cancer data set that we used in the previous video. We also need to do some modifications with the columns here. So you can comment out this thing here, and then these are the attributes that we're going to use now. So the CPU usage and the memory usage and priority and so on. Otherwise, it should be the same thing. So let's see what happens when we run this in here. So one of the things that you can think about is how will you calculate the sensitivity and the precision here, because this is not a labeled data set, meaning that I don't have a, a real number, like if it was anomalating or not in this data set. This is just processes that I read from my data, from my local computer here. But so you're gonna have an issue with calculating the accuracy with this thing that we have, because there is no label for this data set. On the other hand, it's still gonna have a min and max score with the anomalies here. So if I just run it again, I'm gonna have a different data sample that I'm running the samples with. You can see it's not the exact same numbers. The confusion matrix makes no sense here whatsoever, because these are numbers that doesn't exist. But what I can do is, instead of calculating the accuracy here, what I can do is go into the anomalies, and then I can log a couple of anomalies here. I can log maybe the top 3 anomalies. This is why I used the sort on the previous ones. So yeah, I had some anomalating processes here. Code helper, render, I don't know what this is. It's sleeping. You can take, you see, I just took the easy to use variables like the CPU and memory usage here. It uses some memory here, I think. It's, I mean, who knows? Who knows what this is? Maybe you can use this nice variable here. That would be cool to try and find rogue processes, I guess. And you can one-hot encode this variables here for the users and the command, etc. So this is another use case where you can, like in a live system, see if anything is about to happen. Maybe you can do some predictions with this, like see if you can figure out if you have some rogue processes on your computer or something like this, and use that information. Of course, I get this average score, anomaly score here for this these processes here, and I have no idea why I get them for this data set. So you can argue for that and say, like, okay, how do you know if you're doing it right? How do you know if you have a bug in your implementation? And I think the answer to that is probably that you don't, unless you have some other manual way to annotate the data. That can be quite work intensive. But the good thing with this algorithm is that it might actually be feasible, because in the paper at least they state that this is a better algorithm to use on small data sets. So maybe that is feasible for your use case, who knows. But I just wanted to show you this here mostly because this is also another use case for algorithm. And you can see the sampler have now stabilized a bit here. It's not sampling as frequent as before. So you might want to run it again to see if you can find some other anomalating processes on our computer. Cool. That was, oh yeah, this is, my VS Code is acting up. Cool. Okay, yeah, that was everything for this video. And don't forget to subscribe, otherwise I'll see you in some of my other tutorials. This is actually the last video for this series. I hope you enjoyed it. Feel free to comment if you have anything that is unclear. And otherwise, have a great life. See ya. Bye-bye.